Hello everyone, welcome to our channel Braino Academy. In the previous session, we have been discussing the subatomic particles of an atom, proton, neutron and electron, and their masses. Mass of the proton we studied as 1.6726 into 10 to the power minus 27 kg. Mass of the electron we studied as 9.1 into 10 to the power minus 31 kg, and mass of the neutron we studied as 1.6750 into 10 to the power minus 19 kg. And we started with atomic number and mass number. We started the atomic number and mass number because to know the concepts of isotopes, isobars and isotones, it's the important concept that you should have to know. You should have to know the concept of the atomic number and mass number before proceeding to isotopes, isobars and isotones. So if you want to know exactly what exactly the atomic number is or what exactly the mass number is, you can type NUCLEI-01 by Braino Academy. Now we are going to start this session with isotopes, isobars and isotones. This is what in this video we are going to cover. So before proceeding to isotopes, isobars and isotones, we should have to know how to find the number of neutrons. So find the number of neutrons of N714. So how to find the number of neutrons? Let's see. We know about the atomic number, that is Z. Z is nothing but number of protons. And we even studied the mass number, that is nothing but number of nucleons. If you want to know exactly what nucleons is, you can refer to the previous session. Next, number of nucleons, it is nothing but the total number of protons plus total number of neutrons. So as you can see here, for mass number we are having the number of protons plus number of neutrons. For atomic number we are having number of protons. If I am subtracting the mass number with the atomic number, I can get the number of neutrons. So how to find the number of neutrons? It's very simple. A minus Z. This is nothing but number of protons plus number of neutrons minus, it is minus, Z means number of protons. Yeah. So as you can see here, it is number of protons and it is minus number of protons. It will cancel each other and A minus Z is nothing but number of neutrons. So if we want to find the number of neutrons present inside the element, we should have to know the atomic number and we should have to know the mass number. These two things are very essential to know. So here the atomic number is 7, Z is 7, here the mass number is 14, then the number of neutrons is equal to, number of neutrons is equal to A minus Z, which is nothing but 14 minus 7, which is equal to 7. Therefore, the number of neutrons is equal to 7. So it is how we should have to find the number of neutrons for various elements. So let's do it. Now we are going to start to know what is isotopes, what is isobars and what is isotones. Isotopes. of the same elements whose nuclei has same number of protons and different number of neutrons. So as you can see the definition, atoms of the same element whose nuclei has same number of protons and different number of neutrons. As you know already, inside the nucleus two subatomic particles are present. One is the proton and second one is the neutron. So we are going to speak about the protons and the neutrons here. The protons should be the same and the differing subatomic particle is neutron. So as you can see here in the example, it is C612, C613 and C614. As you can see here, the number of protons is same, here 6, here to 6 and here to 6. As you can see, the number of protons for the carbon element is same here, that is 6, 6, 6. And you can see one more thing, that is I wrote atoms of the same element. Atoms of the same element means what is the characteristic property of the element? Characteristic property of the element is atomic number. As I referred, it is the same element, that means my atomic number is going to be the same everywhere. As you can see here, my atomic number is 6, 6, 6. That means if the atomic number is same for an element, then the given all the elements are the same element. And you can see here all the elements are carbon. Right? So atoms of the same element whose nuclei has same number of protons. Same number of protons means our atomic number should be same. Z should be same. Right? So here you can see Z is same. And now I am moving to the number of neutrons. As you can see here, I am going to write here number of protons 6, 6, 6. Number of neutrons here 12 minus 6, mass number minus atomic number. 12 minus 6 is 6. Mass number minus atomic number. 13 minus 6 is 7. Here it is 14 minus 6. Mass number minus atomic number is nothing but number of neutrons. It is what we see now, right? So 14 minus 6 is 8. So you can see here, for each and every element, even though my elements are same, the number of neutrons are varying. As the number of neutrons are varying, I can say that the given elements are known as isotopes. So whenever the given number of for the given elements, if the number of protons are same and the neutrons are varying, then we should have to say those elements are isotopes. As you can see here, right? You can see here it is nothing but mass number. Mass number for the carbon element is getting varying. So I can write A is different. Mass number is different. So we can make one more definition, that atoms having same atomic number but different mass number is also known as isotopes. Atoms of the same element having same atomic number but different mass number is also known as isotopes. So this is the two definitions we can make for the isotopes. Now moving ahead to isobars. So definition for the isobars is atoms of different elements whose nuclei has same number of nucleons but different number of protons and neutrons. Example you can see as carbon 614 and nitrogen 714. So definition of isobar is atoms of different elements, and speaking about different elements, that means my element is going to be changed. As you know, whenever we are speaking about the different elements, as I already said, the atomic number is the characteristic property of an element. If we are speaking about the same element, my atomic number should be same. If I am speaking about different elements, then for sure my atomic number is going to be vary. As my atomic number is getting vary, I can say the number of protons will also be different. Right? Because what is the definition of the atomic number? Atomic number is nothing but the total number of protons present inside the nucleus. Yeah. So as you can see here the number of protons and number of neutrons. If I add the number of protons and number of neutrons, I will get the number of nucleons. Yeah. So here the number of protons is 6. Number of neutrons is 8. As you can see, mass number minus atomic number, 14 minus 6 is nothing but 8. Yeah. Here the number of protons is 7. The number of neutrons is 14 minus 7 is nothing but 7. And I am going to add this one. It is 14 and it is 14. So as you can see here, the number of nucleons is same, but the number of protons and number of neutrons are varying. So once the given elements are varying with the number of protons and with the number of neutrons, we can say that the given elements are known as isobars. Right? You can see one more. It is the atomic number. It is the atomic number which is varying here. So atomic number is different. And here you can see it is the mass number. It is the mass number. Here the number of nucleons is same and number of nucleons is only known as mass number. So I can say that the A is same. So I can make one more definition for the isobars is atoms of different elements having the same mass number but different atomic number is known as isobars. So as you can see here, the number of protons is different, number of neutrons is different, but the number of nucleons is same. If the given elements number of nucleons is same, then we can say those elements are known as isobars. Now we are moving to our third definition for the isotones, or third concept, isotones. Atoms of different elements, whose nuclei has same number of neutrons. If the number of neutrons in the given elements are same, then we can say those elements are known as isotones. Example, as you can see here, Here the number of protons, it is 6. Here the number of protons is 7. Next, number of neutrons. Number of neutrons, here it is nothing but 13 minus 6, A minus Z, that is 13 minus 6, that is equal to 7. Yeah, that means it is 7. Now here for this nitrogen element, A minus Z, it is nothing but 14 minus 7, that is equal to 7. So I can write for the number of neutrons in the nitrogen element is 7. Right? Here the number of nucleons, 7, 6, 13. Here the number of nucleons is 14. So as you can see here, the number of protons is different, the number of neutrons is different, and even the number of nucleons are also different. If all the three is varying, then those elements are known as isotones. But one thing will be same, that the number of neutrons, right? So the number of protons is varying and the number of neutrons is remaining the same. You can see here the number of neutrons is same, but the number of nucleons is varying. So if the number of neutrons is same, we can say that the given elements are known as isotones. As you can see here, now we can see it is the atomic number. Atomic number is different. And it is the mass number. Mass number is also different. So in this isotone we can make one more definition, that is atoms of the given elements having different atomic number and different mass number but same number of neutrons is known as isotones. It is the second type of definition for the isotones. Right? So I'm just summarizing you up. We studied about isotopes, isobars and isotones in this video session. Isotopes, I'm just giving you a short conclusion. In isotopes, number of protons should be same. In isobars, number of nucleons should be same. In isotones, number of neutrons are same. So in this video session we covered isotopes, isotones and isobars, and we even came to know how to find the number of neutrons for the given elements. Right? So in the next lecture we will be coming up with a video based on the shape, size and the density of the nucleus.